Okay. Hello, welcome back to another session on C programming. Ooh. I know it's been quite a long time since we had another video on C, but yeah, it's here. So let's get started. Let's get programming and let's get doing things. I'm sorry. Yeah, let's get into it and let's start. Um, yeah. What did I want to say? Yeah. First things first. Today we have on our menu, um, structs. So we're gonna be talking about structs a little bit and just objects. So let's talk about the fact that there are no constructors. So there are no objects in C. So native C doesn't have objects. So we don't have objects, right? Like in a C++ where you have your class, that doesn't exist in C. Instead, we have something called a struct. So this video we will cover. In this video. So let's just do it like this. So in this video we will cover structs. Then I also want to cover with you typedefs. So to make programming a bit easier, we can use typedefs. And then I'm also gonna cover the heap allocation, dynamic allocation, basically on heap. There we go. So let's talk about structs first. So number one would be structs, right? So structs are kind of similar to objects. So in C++ you would have a class, right? So you have a class and then you basically do like public whatever, right? So this would be like your typical class, right? So you would declare a class something. You could have a template. None of that exists here. So instead, we can... Oh, I'm going to also talk about function pointers as well. So there we go. So these are the 4 things I want to cover with you today. So structs are kind of like classes. They hold data, but you don't have any constructor functions or anything. You could make a constructor function that returns a struct, but we'll talk about that later in more advanced concepts when we cover it. We will get to that when we get to that. So, for example, a simple struct will be just declared with the struct keyword, and then you can store a bunch of data in there. So it's just used to store a bunch of data in one place. It's kind of like a class, but not really. You also don't have this keyword either, so forget about that one. I guess I should stop rambling so much. So that would be the number one structs. So we can allocate structs, initialize them with memset, just like so structs, they can be initialized using memset. And in fact, the zero memory function kind of does this. So there we go. And yeah, so they can be initialized using the memset function. And we can use malloc and calloc. We can use malloc function here to basically allocate our pointers to our structs. So there we go. So that was that's the brief introduction done. A brief little kind of like getting familiar with structs done. Let's now move. Let's actually program something, shall we? So first things first. Let's make our first struct. So the way we would declare a struct or a structure would be to use the struct keyword. So this keyword right here declares a struct. Now what we want to do is we want to give it a name. Let's give it a name. Let's say sample. Let's go sample data, right? Or whatever. It can be literally any name. So let's give this a name. Let's say sample data, right? So this is our struct. Here we wanna basically yeah, so I'm thinking about how this is gonna be done correctly. Here we can basically declare like ints and chars and whatever. So here we can declare a bunch of data. But I'm trying to find out what the order is. So structs, obviously they hold some data, and this data is declared. So we declare this data from, I think it's from largest to smallest data type size. So yeah, so you would have your integers first. So for example, int, let's say data 1 right here, then int let's say data 2 would be a bunch of data, and then you would have a char, let's say let's say operator, for example. So let's say we want to hold some data. I don't know. Let's say you want to hold some, let's say like account data, right? So let's say we have some account, and then we can hold some account data. So we have integer would be first, because integer is 4 bytes. So we have, let's say we can have we can, let's say, have an integer, for example, for like age, for example. Actually not account data, let's just say person. So struct person will have int age, right? We're gonna have another integer, for example, age. You know, like this, we can assign -1, for example, if the data is undefined, you know. And then here we can then say, so this will be these will be first because they're the largest. And then we can have const char. This is also 4 bytes, so const char pointer is 4 bytes, so this will be after. For example, date. So for example, birth date right here. And then we could say, let's say, char initial, right? So we go from largest to smallest, right? So we have 4 bytes, 4 bytes, 4 bytes, because it's a it's a char pointer, and char pointer is 4 bytes, and this is 3 bytes. So if we allocate this memory, this will be 4 bytes. This would be 4 bytes, and this would be 4 bytes. I think char pointer is 4 bytes, or is it 2 bytes? Should be 4 bytes, and this is just 1 byte. I've explained this in one video, so it goes like this. So the entire size of this struct would be to just add all of these together, as long as you have them from largest to smallest. So I'm actually gonna test out what is the size of a char pointer, because I want to get this right. So you just do sizeof char pointer like this, for example, and this will give you the size in bytes of what char pointer is. And char pointer is actually 8 bytes, so it's actually 8 bytes. Damn, that's 8 bytes. So this would be 8 bytes, which means this is actually the largest data type here, which means we need to put char pointer as above here. So const char pointer name, and we can have another const char pointer let's say birth date. There we go. So now this goes 8 bytes. There we go. 8 bytes. And then 4 bytes, 4 bytes, and 1 byte. There we go. I think this might be different now because I changed this. So I'm using GCC now, so this might be different. No, this is still 4 bytes, okay. I'm actually going to check what size is void. Since I'm using GCC, I think this should be 1. I think GCC takes void as 1, doesn't it? Yeah, there we go. So I actually changed my compiler from the last video, and I'm using GCC now running on MinGW because Visual Studio is giving me PTSD. But yeah, so as you can see, GCC, unlike MSVC takes void as 0, but GCC takes void as size 1, which means that if you're actually compiling with GCC, we can actually be more flexible and that we can do a lot more stuff here. So that's one quirk. So MSVC, that has that's part of the god-awful Visual Studio, it takes void as 0, and GCC, which is the better compiler, takes void as 1. So that's the main difference between the two compilers. So right now what we want to do, so now that let's just ignore that rant right now. I'm just going to focus on this. So this is the struct person. So this is a person. Like, just imagine this, sort of like if you come in from, let's say, like Python or whatever. So what we are doing here, so class. So let's basically try to translate this to a bit more of an object-oriented way. So maybe you people that coming from like Python or maybe like C++ can see this a bit better. So this is basically class person, right? So let's translate this into Python. So class person, you would do the double dot, and then you would do, let's say, so you would do the double dot right here, def, let's say, yeah, let's do like 2. So def init right here, self, and then here we would say name, string, then we would have birth date, which would be a string again right here. So that's where we are right here now. So we are basically translating this to a Python class. Now we would have age, which would be an integer. Then we would have weight, which would be an integer. And then we would have initial, which would be a single character string in Python. Great, awesome. So now, what I want to show you is that this is similar, right? How similar these are. So here we would do self name equals name. So this is like specifically like Python initialization right here. Self dot birthday equals birthday, right? And then self dot age equals age. Self dot weight equals weight. Self dot initial equals initial, right? This. So this is basically a kind of what we're doing. So this would be similar to Python. So this right here is basically this right here. So we're basically just like making a class that holds these values right here. We are passing it into this constructor, but in this case they're basically hard-coded. But the Python equivalent would be something like this basically. Just to kind of give you an idea, so that's a struct. The way we initialize struct is not like this. So we can now use this struct because these are uninitialized variables, so these values don't contain anything. Right now I'm also gonna give you the size of the struct. So this struct has a certain size to it, right? For example, so this is 8 bytes, 8 bytes, 4 bytes, 4 bytes, 1 byte. So I can now basically go and print the size of the struct. So technically, ideally, the reason, okay, I'm gonna come back to the reason why we are basically declaring it like this is because if you don't declare it from largest to smallest, you will basically waste memory. So that's why. So ideally, the size of the struct should be all of these added together. So that should be like the our size. So let's check that out. So sizeof. So the way we now try to access this struct is that we say struct, and then we say person, and this is how we basically instantiate our struct. So you need to say struct and then person and then the name of your variable. We'll get to that when we get to that. So now we can actually get the size of this struct right here. So let's do that. Let's see. Let's check how large our struct is, how much it actually takes up in our memory. As you can see, it takes up 32 bytes. So let's see. 32 bytes. So let's go ahead and do some quick math right here. So right over here, I have a calculator. So let's see. So 8 plus 8 plus 4 plus 4 plus 1. All of that is 25, as you can see. So as you can see, it's 25 plus we also declared a struct. So this I think would be 10 bytes in and of itself. So let's see how many bytes that is. So 25, so that's 32 minus 25. 32 minus 25. That's 7 bytes. That would be 7 bytes just for this struct alone. So struct data, so you can have an empty struct. And I think this still does take up space in memory because you have to allocate the struct itself. Yeah, 0. Okay. So there we go. Maybe there's something I'm missing here. I think char should be still 1 byte here. Yeah, that's 1 byte. Okay. It should be declared from smallest to largest like this. From largest to smallest. Yeah. I'm gonna try because I don't really remember, but I think it should be from largest to smallest. It should be that. I should be correct, but I think this is just gonna waste memory, but then we go. I'm gonna compare. I just want to compare these two because I guess it's fair to like still call Steam compare it. So this is from smallest to largest, and this is from largest to smallest. So let's compare those two. So struct person is 32 bytes in size, and struct data is how many is this in size? Also 32. Okay, yeah. So I guess for GCC it doesn't matter. I guess it depends on which compiler you use. I'm using GCC, but ideally I always allocate the... So this is a pointer right here. Yeah, so for example in this struct right here we have altogether 25 bytes of data we store. So we're storing 25 bytes of data in this struct right here. And then so yeah, I mean it's just to explain how much memory are we storing in this struct right here. The differences between compilers isn't that bad, but there are like subtle differences between compilers for C. Like there are, and you have to kind of be careful because they can kind of fuck you up sometimes. You know, like they're not massively different, but there are like some really subtle differences. Like like I showed you with the void, where like GCC takes the size of void as 1, while MSVC takes it as 0. So there are differences between compilers. So you know, I need to just get used to this. But there we go. So we have altogether 25 bytes of data in this struct. So then, right here, we are going to initialize this struct. So how do we actually make an instance of this struct? Well, there are two ways. We can initialize this on the stack, like with the other variables. We can initialize it on the stack, or we can dynamically allocate it on the heap. Let's show ourselves. Well, first let's show the first option. So like just allocate it on the stack. So let's see. So to allocate a struct, we want to say struct. We always need the struct keyword there. So struct, and then let's say person. And then here we want to give the variable a name. So let's name it, let's say Mike. Like this. So now we've created a struct called person called Mike. And now I can access these variables. So I can say Mike dot, so we access the fields in our struct through dotted notation, just like you would in a class. So let's do Mike dot, let's say age, this one is 0, right? So there we go. But right now we can't really do anything with our struct because it hasn't been initialized. And the way that we can do it is we can use this, I think we can use curly braces here, or I don't think this works. I think that's only C++. Anyway, let's do it the C way. So the way we want to prepare our struct to be used is to use the memset function, the ones that I've been talking about in the last video. So here we provide a pointer to our struct. So here we need to provide a memory address of our struct, like where, like a memory, like a reference to our struct, right? Like where is this struct located? So we need to do and this ampersand and say Mike. So this is our memory address that we need to zero out. I want 0, and then here I just want to say sizeof, let's say Mike right here. So that would be the way we can initialize a struct. And now we can start using this struct. So let's say we can print, I want to print, let's say a number. So I want to print Mike.age, and this one's going to be 0 because it's been initialized to 0. So now we can print this and it's going to be 0. It's going to say, oh, 0. Cool. Now we can, let's say if I print like name over here, it's just going to say nothing. It's just going to spit out a 0, as you can see. So as you can see, it's basically all just 0. So you can also make a function for this, but you know, it just means that there's nothing in it. Like there is just nothing there. So all these variables are now empty. So now we can write to them. So now we can initialize them. So let's initialize our. So we can proceed. So here we have, right here we have prepared struct for writing, and reading. So now we can prevent any memory errors that we get. And now we can actually assign data to our struct. So let's do that. So Mike.age, let's say it's going to be equal to 21. Let's say Mike.birthday is going to be, let's say, 11. There we go. Mike, let's say we can say name. We can say Mike right here. And we can say Mike. We have birthday, name, age, maybe initial. We can put it like M there. Oh, single quotes. Remember, char is single quotes. So yeah. Oh, I totally forgot about talking this. So I'm just gonna do a quick mention here. A string is denoted by double quotes. So that is a string. And single quotes denotes a char. I think I should just mention this just offhand really quickly. And then let's see. So we have age. Oh, wait. let's put like 100, like 1 ton. There we go, 1,000 kilos. There we go. So now we can basically start reading. So let's then read data from our struct. So there we go. So now we can proceed to read data from our struct. So how do we actually read the data? Well, we're just going to use our printf function, and then we're going to choose the correct format. And then here, let's say Mike dot, let's say age. So I want to print, let's say age right here. So now it's going to print 21. So let's do it. Let's run. There we go. So now it prints 21. Okay, cool. So I want to print a string now. So let's say Mike.name. So I want to print a name right here. And it prints Mike, as you can see. So now we have successfully created our struct. We had prepared our struct for writing. And then we have assigned a bunch of values to make sure that they're not null. And then we can just print them and we can start using our struct. There is a way of actually using functions to initialize our names and everything. So maybe now we want to probably create a function that initializes our struct for us. So maybe we don't want to do it like in main, right? We don't want to do this to main. Like, hey, you know, we want to assign this dynamically. So let's see. We can create a function of type void. We can say, okay, cool. So we now know how to assign values to a struct, how to zero out our struct. Right here, they will keep this function because we will need it. So right here, go right above your main function, and let's create a function that prepares our struct. So maybe, you know, just to make it easier for people maybe that are using our library to kind of create this struct in a way. So, you know, we can hold data here. We can obviously put like, let's say 12 or whatever, but yeah, let's not do that. Right now, what we want to do, like we can just say like 12, right? So we can do it like that. But I don't think we can do it here. Yeah. So the easiest way is to basically create some sort of a function that allows us to set the values in our struct in a very more of like an abstracted way. So we don't have to like go one by one in our main function and set it. So okay, go ahead above your main function and let's create void. And maybe let's name it whatever. Set data. Let's say set person data, right? And here we can basically create. So we can say const, right here, const char. Go ahead and create a const char pointer name. Then const char pointer birth date. Right here. Then create const integer. Then just say int age. Int weight, and then maybe let's do char initial right here. Char initial. Cool. All right. So let's create a function that looks something like this. So we don't return anything, and we just want to set person data. So it's easier for us to actually go ahead and set the data for us. So what we want to do is we need to take this. So this is kind of weird, but there's a way to pass by value and pass by reference. So what we need to do is to be able to actually affect the struct is that we need to pass in like right at the end here. Let's go right at the end and here. So right at the beginning, before anything, we need to actually take this struct as a parameter. But how do we do that? Well, that's actually pretty easy. Let's go ahead. So repeat after me. So the way that we need to pass this struct that we have, this right here, this person struct by reference. Because if we pass it by value, we will just make a new copy of it in this function that basically only lasts within this scope, which means it's actually not really going to affect this actual struct that we created here. So for this to happen, we need to take a pointer. So we're gonna say struct right here, struct, right? So it takes in a struct person, and it's a pointer. So person, and then do a pointer right here, okay? And then say person, okay? Right here. There we go. Just to differentiate it a little bit. So here, just to make sure that, you know, it doesn't get confused between these two. So this right here, basically what this is, we're asking, hey, can you please provide the memory address of your struct to this function? That's what we're basically asking. So to anyone who uses this function, we're basically asking them like, hey, can you please provide the memory address of your struct that you want to actually initialize? That's what this little star means. So it's a pointer to a struct, which means the memory address, you know? So right here, we can actually just initialize our struct. So we can say person, and not dot, okay? So if you're dealing with pointers, don't put the dot here. The correct notation is to use the little arrow. This arrow right here is used to deal with pointers. So for example, name will be equal to name right here. Person dot, let's say, birth date will be equal to birth date. Person, let's say, age will be equal to age. Person, weight will be equal to weight. So let's just initialize our struct right here, and then initial will be equal to initial. So there we go. So now what we have to do is just simply use our function right here. So as you can see, let's do some print stuff. So let's print our struct. So person, someone is years old, and you know, years old and years old. You know, for example, years old, right? Then we can say birth date will be a string, and then we can say weight will be %d right here. So now we have everything right here. So now we will say old. Let's put a new line here just to kind of differentiate it. So now Mike.name. We need to provide Mike.name. Let's do, so we need to provide a name to this. Let's give it age. Let's do maybe birthday. So birth date would be there, and then the weight. There we go. So this right here now will all contain just zeros. So as you can see, this will be 0, 0. As you can see, person and null is 0. So as you can see, this string right here is null. It doesn't contain anything, right? It's because it's been initialized to 0. So as you can see, person null, the name is null, is 0 years old, birthday is null, weight 0. Because all of these fields after calling the memset function here are 0. They're all set to 0. So there is no real data here. So now let's use our function to initialize our struct in a more reasonable way. So let's call setPersonData. There we go. SetPersonData, and it wants all this stuff from us. Yeah. So it wants a struct pointer to a person. It wants name, birthday. So let's actually do it. So now this first thing, it was a struct person pointer. Okay. So just like with the memset function, this is basically asking, can you please give me the memory address of your variable? So let's give us. So again, it goes ampersand and then the name of our variable, Mike. So this is the correct way to do this. Then we provide a name, Mike. So this would be just a simple string. This is a simple string, 11, 11, 11. Then this is just a simple age, number 21, weight like 666, there we go. And then initial will be, remember, the little 1 thing right here would be M. There we go. So right now we have everything that we need. Let's call printf again. So call printf. So let's call our printf function again. And this should have worked. So shift, sorry. There we go. So this should have worked. So let's call this function again right here. So let's copy, let's paste it right here. So let's call this function again. And let's see what happens. I'm just gonna put rn. And then here I wanna say just to make sure that it's like done, you know. Here I want to say that, you know, we basically initialized our struct like this. So you can create these like little functions that initialize your structs, you know, just so you don't have to set it one by one. You know, so this technically right here, technically speaking, this could be called the constructor function, even though it's really not, but yeah, you know, that's why I put it in the quotation marks, like the, oh, sorry about that. Like the, you know, the constructor function. It's not really, but, you know, for the sakes of, you know, comparing it to other languages, let's call it that. So let's do that. So let's print this, and you'll see that after we call setPersonData, we're gonna have some data in our struct, because in the main function you really don't want to be going around and saying like Mike.weight equals, you know, whatever, right? Like you don't want to be doing that in your main function. You kind of just want to be calling other functions from your main function. Like you kind of, this is kind of what you're aiming for your main function to look like. You don't really want this right here in your main function. That's kind of like a big no-no. You know, because it's gonna make it very messy and very unreadable. So just remember that, okay? So now let's just hope that it works, because again, I'm sorry that I like switched compilers, you know, like GCC from MSVC, and it's just been a whole nightmare. So I hope this works, because I'm not really familiar. Yeah, there we go. Look at that, it works perfectly fine. So here, as you can see, before calling our setPersonData, everything is null. And then after we called setPersonData, you see these values are now initialized to their proper values. So as you can see, it's because of this. So we have basically passed this variable right here by reference, as you can see. So by value, it would create a copy of this variable right here. And this would basically just be assigned to the copy of the struct, which lives only in this scope right here. So that copy of the struct only lives in this scope. And if it goes out of this scope, that struct disappears. And this struct is going to remain unchanged. And that's the reason why we're using this pointer right here, and then using this ampersand. So we're saying that, hey, I want to change the struct at this memory address right here. Like, this is the one we want to change it at, like, this memory address, you know? So it's like to avoid creating copies of your struct, we just say that, hey, this memory address is the one I want to work with, you know? So it's you're basically asking the person using your function here that, hey, give me the memory address of your variable that you want to change or initialize or whatever. That's exactly what we're doing here. So as you can see now, we have a way of actually doing this, setting our variable and our data in a very nice and concise way, so we can work with it very well. So we can like work with it and initialize it and blah blah blah. Okay, awesome, great stuff. So yeah, I think that's it. Okay, that's it for stack initialization for now. So let's delete this. So that concludes structs or initializing on basically, yeah, so that concludes the stack initialization over struct. Sorry, I'm just kind of thinking about stuff. So there we go. So that's what we wanted right there. Now let's move on to, let's try to work a bit with the heap. So I'm gonna introduce you to the heap. So heap is basically like something like a stack, but you need to actually use functions to allocate stuff to it. So you manage that memory yourself. So let's do that. So I'm gonna go and first introduce you to how we can to the simple data types. So for example, we can allocate certain things in heap. So for example, there was this way. So we can say char pointer string, right? We had this. Hello. So this one automatically appends the null terminator at the end. That's what we were talking about last time. Then we were talking about this right here. This right here. So how this one initializes everything to 0, but you need to be careful to not overwrite that this last null bit, otherwise you're gonna get troubles. Now we're gonna talk about the heap initialization. So we can do this. So we can either do this, or there is another way of doing this, which might not necessarily be right, but which is not exactly the correct way of doing it. But I just want to show you that this method exists. So we're gonna declare a char pointer. So repeat. So now we're gonna try to assign a string on the heap. So repeat after me. Char. So char pointer name. Let's go with Laura. Here we have a name, right? So we can make a name like this. But there's another way we can actually assign a name to this variable. So we need to cast this. So a good practice is to make sure that you always cast this void pointer that's returned by the malloc and calloc functions. Because if you look at the calloc, as you can see, it returns a void pointer right here. It's always a good practice to remember to cast this void pointer, because if you're gonna go from C to C++, you're gonna get confused, because C doesn't necessarily strictly whine if you don't cast it, but C++ will bitch at you if you don't. So it's always a good practice to just keep that consistency going between languages. So I'm just going to cast this to char pointer. And here I'm going to say calloc, because we are allocating a contiguous space in memory, because characters go right after each other, right? It's like an array of a sorts. So that's why calloc. And as you can see, it requires two parameters. It requires num of elements and size of elements. So this is the num. So let's say, so that would be, Laura has 5 letters, right? Yeah, 5 letters. So we need 6 because of that null terminator in there. And then here we go sizeof and char. Char, right? So char. Okay, follow still. I hope you're still following, right? So there we go. So that's the size of elements, would be the size of char, so 1 byte. And here, now, this is just an empty, so this automatically initializes your variable to 0. Now, what you want to do is we want to use the str copy. So we can, I'm just going to include another include right here. We want to include string.h. So what we want to do is we want to copy a string into this variable. So how do we do that? Well, we use the str, so str cpy, char copy, right? String copy. And here it will take you the destination, right? So the destination is a pointer. Well, we have a pointer, so let's go name. That would be the destination. And then there is another saying the source. The source will be, actually we probably want to use the safe function. So CPY, yeah, this one right here. So this one takes destination, which would be our name. So that's our destination. Where do you want to save the string that you're copying? Okay, size in bytes. This is the size of your destination. Okay, remember, size of your destination. This right here is the size of your destination. Well, we can't just do this. Okay, so some of you might think, okay, well, size. So I'll just use the sizeof operator right here. Oh, size of name. This size of name, and then I'm just gonna. So here on the in the last parameter that says source, we can pass by value. So we can just say Laura, right? So this would be our source, right? And some of you will say, okay, well, I'll just use the size of name. But this is actually wrong. Because remember, if we are initializing like this on the heap, if size of name, what this actually does is you're actually doing size of char pointer. I've already warned you about this in my last video. So this is actually what you're doing, and this returns 8 bytes in this case, which is obviously large enough to hold the name Laura, but is not going to be large enough to hold any other larger strings, even though we have allocated, let's say if we allocate like 128 bytes. If you do this, you're only going to be this function will only allow you to store strings that are only 7 bytes in length. So 7 characters, or 8 characters if you count the null terminator. Which means that you're wasting all this memory right here that you've allocated. So all this like 120 bytes of memory right here will get completely wasted. It will be just worthless. So that's the reason why we need to actually pass this by value, and we need to say 6. Because that's the size that we're allocating here. And so 1, 2, 3, 4, 5. So this should fit into our buffer. So we should be able to actually copy the string Laura right here into our variable name. Then what we want to do is we need to print it. So let's print our string. And since this is a string and it takes treated as a string, we don't need to dereference. So we just say name. There we go. Bam. There we go. No dereferencing needed. And right here, what we do is at the end, if you want to use the calloc or malloc function, always remember to use the function free. So now we are done. If we're done using our name variable, we simply just call free like this, and we just simply say and a memory block that we want to free. That would be the variable name. There we go. So this free right here, it kind of works similar to delete. Delete something in C++. So that's kind of how this works. And now here, this is, now we don't have any memory leaks anymore. So there we go. Right here. So now if we run this, we should be able to see that it prints Laura. So let's hope that it does. There we go. Laura gets printed to our terminal. Hey, there we go. Awesome. Well done. If you're following up and you managed to get to this point, good job. You're doing very well. There we go. So now that we have allocated on the heap, we have copied the name, like here. We have copied the name Laura into our variable. We printed it, and then we freed the memory back. We gave the memory back to the computer, and we do have no memory leaks in this program anymore. So that's good. Now we can also do this with integers. So let's do something a bit different. So calloc allocates arrays. Malloc allocates structs. So let's try to maybe do an integer array. So I don't know. Let's see. Oh, by the way, I also forgot to mention, this can get treated, you can treat this as pointers. You can obviously treat this the same way as pointers. So if I put 0 here, which is a char, not a string, this will print the letter L. So right here, the letter L. I can also kind of change the offset of this. So if I say +2, plus 2, this should print URA. So there we go. As you can see, it prints URA. So you can do standard operations like this as if it's a normal pointer. Just a little side note, just so you don't get confused. All right. Next up, integers. So let's try to allocate an array of integers. Okay. So let's do int. Okay. Let's go slowly. Int. Then let's allocate. Let's call it a pointer, and then say numbers. Okay. This will be equal. Remember, again, we cast, but in this case, we cast this to int pointer. Remember, we are creating creating an array, therefore it's a continuous space, so we call calloc. Size t is the number of elements we want to have in our array, in this case 3. And the size of elements, this is going to be 3 times 4, like this. Why 3 times 4? This is going to be 3 times 4. Why 3 times 4? Because integer is 4 bytes in size. Or, if you don't want to do it like that, you can just go sizeof int. And this will automatically do 3 times 4 for you. So basically, it's not 3 times 4, sorry. The whole thing is 3 times 4, but this is just 4. So this would be 4 right here. So you can put 4. Right here you can put 4, or you can put size of int. It's the same thing. But I recommend using size of integer. Like, I recommend doing it this way. It's much safer. You don't have to remember all the numbers and stuff, so, you know. Next up, now we can this basically initializes all of the numbers inside our array to 0 already. So we don't have to actually do it ourselves. So if you just say, let's say print fs d, let's say number is 0, this will already give you a 0. Because it's already initialized to 0. There you go. Right here, as you can see, it's 0. As you can see, all 3 were already initialized to 0. I created a memory leak, but we'll get to the point. I'll just wanted to show you that it's indeed all initialized to 0. So now we can basically just assign, let's say numbers 0 is equal to 1, for example. Numbers 1 is equal to 2, and let's say numbers 2 is equal to 3. So it's 1, 2, 3. Again, indexing starts at 0, length is 3, right here. So 3 numbers right here, and it's 3 times 4, so the whole thing is size 3 times 4. So there we go. Right now, so now we can just print. So let's print D. So I want to print all 3 of these. So let's say numbers 0, numbers 1, and numbers 2. There we go. So now this will print 1, 2, 3, as you can see. And then, just like last time with the string, we call free to give back the memory back to our computer, prevent any memory leaks. So the general rule of thumb is, I'm going to write it for you up here. So the general rule of thumb is that if you are using malloc, or calloc, you should use so always use free at the end. There we go. So always make sure to use the free function right here at the end. So to basically prevent any memory leaks, because that could screw you over. So there we go. 1, 2, 3. Awesome. Epic. Now you have created a little array of integers. Well done. Good job if you got this far. You're doing well. Now, let's look at how it would be with structs. So, let's see. Structs. How would we allocate a struct? Let's say let's say, on the heap, right? Like on the heap. Well, remember, structs can be like this. So we can write structs. So struct, let's say, person and mic, right? So this is allocating it on the stack. But then we can also allocate it on the heap, right? In this case, we can still use the same function right here because it's still going to return a pointer. So right here, so it's kind of similar but not really. After this, I'm going to do the same thing but also introduce you to like the typedef version of this struct. So for example, here I can say struct, because it's always good to know the basics, you know. Struct, the name of your struct, in this case person. Okay, good. And then let's do pointer, right? And let's call this mic. Let's call this let's call this any other name. Let's just go with mic for now because it's short. Mic. Now let's put this equal to, let's say, what should we put this equal to? So this is we are gonna do the same casting as we did last time. So put your little parentheses, and then again, then you do something like this. You say struct person and pointer. So again, we need to say struct, otherwise it's not gonna work. So struct, and then the name of your struct, person, and then pointer. So this is the cast that we're going to do. Now, we're not allocating continuous space. We're allocating just like a memory block or struct. So we're going to use malloc right here. And malloc only requires the size t, which in this case is size of the struct person. So what size of memory do we want to allocate? So sizeof, right here, sizeof, and then again type in struct person. We need to say the every time we wanna work with our struct person, we need to say struct, preface it with struct, and here this will already allocate everything to null. So let's say d mic and then arrow because this is a pointer. Okay, age, this would be 0. Oh, I don't think, yeah, so this is 0. There we go. Beautiful. Now we can do the same thing. We can call our setPersonData like function right here. SetPersonData, and in this case it indeed takes a struct person pointer. Well, we already have it. We have a person mic, and like right now as it stands, we do not use the ampersand right here because this will give you a double pointer. So you don't want that. So we don't use an ampersand. We just simply put mic here because, as you can see, it already is a pointer. Like this variable right here already is a pointer, which means we don't have to dereference it. So here we just simply say mic right here. Then we just say, let's say birth date 11/11/11, and then let's say 21, and then let's say let's say 21 666, and then initial would be, let's say, M, like this. Capitalize it all nicely. And right here, now we can actually print our struct. So let's print, let's say, mic, let's say name, S, and let's print the age as well. So let's print the age right here. So mic, age. There we go. Again, remember, after we're done using our struct, called free, and then mic. There we go. That's the memory we want to free. So now this should say in our console, mic 21. That's what it should say right here. And indeed, that's exactly what it says, mic 21. And the reason why there is not an ampersand here, as you can see, if I put the ampersand here, it will give me a warning. This IDE will actually warn me. It will say, hey, you see, incompatible pointer types passing struct person double pointer to parameter struct person pointer. So as you can see, this is actually the problem that gets created when you put the ampersand here by mistake. You're actually passing a pointer to a pointer, because this mic as a variable already is a pointer to a memory address. We can just do it like this. Remember, the ampersand is only valid if you, for example, allocate your struct person, let's say, Laura, like this. Then, for example, if I pass in Laura, then I would put an ampersand and say Laura right here. If I want to pass in Mike, I would just say Mike without the ampersand, because this is already a pointer, but this is not. So that is the main difference that you always need to keep in mind. That, like, you're probably gonna make mistakes on that, trust me. But that's the main difference that you need to keep in mind. So please keep that in mind. It's very important. Very big difference. So there we go. So now we could technically also make a function for printing this struct, but I am already gonna leave that for you. So maybe you can go ahead and make a function, let's say void, that says, let's say, print person data. And maybe I want you to figure out what parameters need to be passed in, if you need to pass in like a pointer or something, and then let's see how you would print. So maybe you can do this one yourself. I don't know. Maybe you can try and, build on this knowledge yourself a little bit. So maybe you can find a way of how we actually print this struct using a function yourself. I think that would be a little bit interesting. Okay. Great. Well, let's moving swiftly on. Let's introduce typedefs. So, yeah, I've already been recording for an hour, so let's not make this video too long. So moving swiftly on, let's introduce us to typedefs. So typedef. What is a typedef? Well, this allows us to define custom types that we can use. So, for example, we can say, for example, a size t. For example, something like size t is an alias. So size t, for example, let's say size over here, as you can see. So this is basically typedef unsigned long size t, as you can see. So this is basically typedef. So right here, I can basically say typedef unsigned short, int, and here I can say short boy. For example, I can say short boy right here, and this I can then use this as a type. So I can, for example, go here and say short boy. Let's say short int, and then I can use this as a type basically right here. It's basically just an alias. As you can see, short boy is an alias for unsigned short. So it's basically just like aliases for maybe more complex types. And I like using these, for example, with structs. So we can typedef the struct person right here to make it a bit clearer. For example, I like capitalizing them. So I can just say, because, struct person, if you want to declare a struct, you always have to do struct and then person and then the variable. And, maybe for some lazy people out there, if you're lazy, that might be too much typing. So here, you go up here and you say typedef, let's say struct person, and then you give it your own name. So I like capitalizing all of these. So let's say person. There we go. So right here, as you can see, person is a struct person. So now we can, instead of saying struct every time, simply now we can just say, let's say we're going to allocate it on the heap just like last time. So let's say, well, now we can basically say, we can basically just say person, as you can see, and then Laura right here. And then we can basically set person data, and now we just simply pass the ampersand right here, just for the sake of a bit of like diversity, you know. Let's just enter the same stuff here. There we go. L, because it doesn't really matter. It's just an example, you know, about how we set things. As you can see, you watch for the use of the ampersand right there, and then we simply just say print. So we just simply print f, and then let's say s, and then d, and then say Laura.a name and Laura.age. There we go. Awesome. Again, we don't have to free memory right here. This is not necessary when you're doing it like this. And as you can see, it indeed does print exactly the same thing that it print last time, as you can see. So this basically just makes it a bit clearer and a bit easier. You can obviously do this as well on the heap. So let's just show each other how this would work. So you put the person, then pointer, and the name of your variable. And now, remember to cast. Always make sure to do that. Put person, pointer, and malloc, and then say sizeof, right here, sizeof person. So then again, as you can see, it's much easier. We don't have to constantly type struct everywhere. Here, let's set person data. Notice how I'm gonna omit the ampersand for this one. There we go. And then here we're gonna print again S and D. So we're gonna print the name and the age again. And then watch how I'm gonna use the arrow instead of the dot, because this is a pointer. So name, like so. Remember to free at the end, always. And now, as you can see, it still prints Laura 21. There we go. Whew! Well, that was a lot that we got through. I think I am going to do function pointers later. So, it's already been an hour. I don't want to make these videos way too long. I'm gonna introduce you to multi. So next up, we're probably gonna do multi-threading and function pointers later, and we're gonna build a chat client and a chat server using WinSock, with the Win32 API. So there's still much that you need to learn, and much that we need to cover. So for now, I'm gonna leave you at this. I'm not gonna bother you for more. It's already been an hour, so let's cut it here, because you know it's just being too long now. So yeah, so I hope you enjoyed this. You can always yeah, so I hope you enjoyed this. I hope this was helpful. You can always, you know, you can always slap the like down there, and you could always subscribe. That would be nice. That would be pretty cool. You know, I'm not forcing you, but I'm just saying, you know, it'll be kind of cool. You know, you would be a pretty big Chad if you did that. Not gonna lie, that would be a pretty big Chad move. But anyway, I hope this was useful and informative, and I'm gonna see you in the next video. I don't know why I'm talking like that. I'm just gonna see you in the next video, bro, okay? Like, probably something else, whatever the fuck I come up with. So, I'm gonna go and stand on a rock outside for 20 minutes and think about my life's choices.